Data analysis. Happy Monday. We had a great weekend. A little brutal yesterday and Sunday. Weather was not nice. But to brighten your Monday, I have a great joke for you. I had a dream that I was eating a dictionary and I woke up with thesaurus throat ever. Thesaurus, I don't know, not too funny. It helps when there's like somebody in the background laughing. So maybe I'll need to pay my kids to be in here when I tell jokes and they can laugh hysterically. Okay, so how do I make a confidence interval for an average or what we'd call a mean? First, let's go over a couple things. So let's say I lined up 100 people and I asked them their shoe size, right? And I said, what's your shoe size? What's your shoe size? All these 100 people, let's say all females, right? Just so that there's no difference between the male and the female sizes, right? Let's say all females. The average female size is, let's say, 7, right? That's right in the middle, average female size. Okay, maybe it's 8, somewhere in there, right? And I want you to think, like, if I were to say, what 2 sizes would capture 68% of my data? That's how much a standard deviation would be, all right? So if I ask 100 people, would 68% of them be between 8 and 6? If the answer was yes, then 1 shoe size is your standard deviation. 1 is standard deviation. Does that make sense? Now, if you thought, no, that wasn't right, and you're like, well, I think actually I'm going to capture 68% of my data between 7 and 9, right? And 7 and 5, that would be 2 would be my standard deviation then. So when you're doing problems like this, we're going to make a few up. You kind of got to think about what the middle number would be and how far you'd have to go to get 68% of your people. So if you asked 100 people what they would say. Let me give you another example. Let's say I make 100 people run a mile. All right. So we're out there at the track running 4 laps. And I say that the average of those people running that 1 mile, the average would be, let's say, 8 minutes, right? And in order to capture 68% of my data, 68 of the 100 people, I'd have to go up to, let's say, 9 minutes and 30 seconds and 6 minutes and 30 seconds, right? I'd have to go up a minute and a half, down a minute and a half, and I'd have 68 of the 100 people. So that would be my mean, which is 8, and then my standard deviation would be a minute and 30, right? Or 1.5 minutes, all right? So when you're doing problems like this, you make them up. You have to make up a mean. You have to make up a standard deviation. So it's just a little bit of thought that goes behind it. Okay, so let's make a confidence interval for an average. And today, I think we're just going to stick with 95% confidence intervals. We'll see if we have time, how long this video goes. All right, so we're going to first make a confidence interval, and let's use what we did over here. So let's say we had 100 people run a mile. Average time, we'll say X bar. Actually, I'll write out the word average time because there's going to be some weird symbols here, is 8 minutes with standard deviation of 1.5 minutes. Now you realize that 1.5 minutes is 1 minute and 30 seconds, right? So that's what we're talking about here. So let's make a 95% confidence interval. The formula is very similar to what we did before with proportions. It's going to look like this: X bar plus or minus some z-score times the standard deviation over the square root of the sample size n. All right, a lot of weird symbols there, but let me show you how to plug it in. Once you know how to plug it in, you can make these confidence intervals in your sleep. Let's try it. So X bar is the average. Okay, so what was the average time? 8 minutes. Okay, 8 minutes plus or minus. Now z-score, since we're doing 95, remember in these curves, whoa, that was the worst normal curve I've ever made. Within 1, standard deviation is 68%. Within 2 is 95%, right? 95% is within 2 standard deviations. So I need 2 standard deviations if we're going to make 95% confidence intervals. And that's what we'll do with this first problem. Probably do one more. Times, now that little sigma That's the Greek letter sigma. That means standard deviation. So you could actually write instead of sigma up here, and we can make life a little bit easier for us and just write standard deviation. 2 times standard deviation of 1.5 over the square root of the sample size. So the square root of the sample size, 100 people. Okay. So that is how we are going to make a confidence interval. So let's grab the calculator. Oops. And let's do a little plug and check here. Okay. So we are going to do 2 times 1.5 divided by the square root of 100, 0.3, right? So 0.3 is the amount right here. So this is 0.3. Okay, that's 0.3. So we're going to do 8 plus or minus 0.3. So it would be 8.3. So 8 plus 0.3 and 8 minus 0.3. So 8 minus 0.3 would be 7.7. Okay. Now we would not need to convert, but here's your final sentence. We are 95% confident that, the runners, well, I'm saying this wrong. The true average of all runners, Now, we can talk about however we want, like we say in Mequon or in Wisconsin or in the United States, of all runners in Wisconsin is between 7.7 minutes and 8.3 minutes. Okay. Now remember, we're trying to find out, like a confidence interval tries to get of all people, right? So if mine came out to be 8, well, that's not for everybody. That's just my 100 people that I sampled. So we got to make it be for everybody. So it's going to be somewhere between those 2 times. And I know 7.7 minutes is a little bit weird, and I don't need you to convert that. Don't worry about that. Just come up with something. No, you're making up the problem. You may not be minutes and seconds. Let me come up another one with like our shoe problem. Okay. So let's go. Grab a few paper here. Let's say that we have, okay, I ask 100 people, and you can use 100 just to make life easy on you. That's completely fine. Their shoe size. And let's make it even better, because if I ask 100 people, I have males and females, different shoe size. So I ask 100 males their shoe size, okay? Assuming that you can group people into males and females. So what is your gender, shoe size? And obviously there's some differences there, but if you could group them into exactly 100 males and say, what is your shoe size? We would go with that, okay? So I know we talked about in class as far as breaking apart in gender, so we don't want to offend anybody. So let's say the average male shoe size was 10 with a standard deviation of 1, 11, 9, 12, and 8, okay? That's going to male's shoe size. The mean was 10. Standard deviation was 1, okay? And we want to make a confidence interval, so 95% confidence interval. All right, so here we go. X bar plus or minus z-score times standard deviation. Again, I use that little symbol sigma, but you can just write standard deviation over the square root of the sample size. So we have X bar, which is the average shoe size, 10, plus or minus. Z-score is going to be 2 because we're making a 95% confidence interval. Standard deviation was 1 over the square root of 100. Again, make it 100 if you like. You can make it 16. Anything that takes a square root nicely is very helpful to you, right? You can make 16 or 25, something like that. So this is going to be 2 times 1, which is 2, and then divided by 10, which is the square root of 100. That's 0.2. So this whole value here is 0.2. So 10 plus or minus 0.2. All right. We are 95% confident that the true average shoe size in, let's say Mequon, say you took all your people from Mequon, is between, trying to write too fast, is between, now 10 plus 0.2, right? 10 minus 0.2, so between 9.8 and 10.2. Right? Now, this is a little bit of a silly one because you can't get a size of 9.8 and 9.9, right? So they're saying that the average shoe size, right? Like we're looking for the average would be somewhere. So of all the people in Mequon, if you ask everybody and you found their average shoe size, it'd be somewhere in between those two. Okay, so that is how you make a confidence interval for a mean or an average of the numbers. Hope that helps. You'll be making up a couple examples, and then we'll be on to a new topic. Have a great Monday. Talk to you later.